Welcome, everyone, to the absolute ultimate science class. In today's Explainer, we're taking a virtual field trip to humanity's most enduring platform for international cooperation, right up in orbit. We're going to explore the daily grind, the wildly extreme conditions, and the groundbreaking research that actually makes this floating laboratory our greatest stepping stone into the cosmos. But hey, before we take our seats, I want you to imagine your classroom zooming exactly 250 miles above the Earth. And get this, it's traveling at an awe-inspiring 17,500 miles per hour. To put that in perspective, they experience a sunrise or a sunset every 45 minutes. That's about 16 of them every single day. So every morning, these astronauts wake up, unstrap themselves from their wall-mounted sleeping quarters, and head to work in an environment that is, quite literally, out of this world. Okay, let's take a quick look at our itinerary for today's trip. We'll start with a welcome to orbit, then head into the Microgravity Science Lab, step outside for working in extreme conditions, and finally, look at the next great leap. All right, kicking things off with part 1, Welcome to Orbit, a global partnership. So, first designed way back in 1984, this fragile framework of modules was built into a massive global outpost by the principal space agencies of the United States, Russia, Europe, Japan, and Canada. Honestly, it's an incredible testament to what we can achieve through international cooperation. I mean, it requires globally distributed flight operations, massive communications networks, and shared engineering just to keep the whole shebang operational. And over its lifetime, this partnership has hosted over 280 visiting astronauts from 26 different countries. Think about that. It truly is a global classroom. It's a place where crews are sharing meals, sharing their cultures, and running their daily routines, all while pushing the very boundaries of human knowledge. Moving right along to Section 2, the Microgravity Science Lab, Space Research for Earth. Let's actually step inside the lab modules and check out the daily research tasks our astronaut scientists are doing. Now, the whole Space for Earth concept really comes alive here. Up on the station, astronauts are actively growing stem cells in a weightless environment. And because there's no pull of Earth's gravity, well, these cells behave completely differently. This lets researchers study them in ways that are just flat out impossible down here on the ground. And the ultimate goal? To radically improve cancer and disease treatments back home. But it doesn't stop there. By studying conditions like pneumonia up in microgravity, astronauts are actually yielding critical advances for our own heart health back on the ground. Think about that for a second. The research happening 250 miles above your head right now, it could directly impact the medicine your own doctor prescribes you in the future. It's just wild. It's exactly like the quote says, "The space station has been our classroom, laboratory, and proving ground." Our astronaut scientists are spending their days running literally thousands of experiments, checking microbe samples, and totally pushing the boundaries of what's biologically possible. Which brings us to Section 3, working in extreme conditions, life outside the airlock. You know, living in microgravity requires some seriously intense daily routines. Astronauts actually have to perform mandatory physical training for 2 full hours every single day just to keep their bones and muscles from wasting away in weightlessness. But the real physical test? That happens outside. Let's break down the sheer procedural drama of a real maintenance task. So back in December 2013, astronauts had to execute this incredibly intense spacewalk operation. It was spread over 4 days, and it was all just to replace a broken water pump on the outside of the station. Just imagine trying to do heavy plumbing while wearing this massive, bulky, pressurized suit, floating in a literal vacuum, and oh yeah, moving at 17,500 miles per hour. Every single movement requires meticulous safety routines, double tethers, and nonstop communication with mission control. And to pull off these extreme tasks, astronauts rely heavily on robotic lifelines, specifically the Canadarm2. This incredible piece of remote manipulator technology actually maneuvers the crew and super heavy equipment right across the exterior. When an astronaut is working on something like that water pump we just talked about, they are anchored directly to a foot restraint on the Canadarm2. Just to keep them from floating away into the infinite dark abyss of space. No pressure, right? Maintaining this orbiting lab is a monumental physical challenge. In fact, it's required an astounding 259 spacewalks since December 1998. And every single one of those spacewalks is meticulously planned out. It requires incredible bravery, rigorous safety routines, and just massive physical endurance from the crew. All right, time for Section 4, the next great leap, preparing for deep space. For our final lesson today, let's explore how living in orbit for the past quarter century is basically serving as our graduation prep for the stars. If we trace the station's history, from its initial design way back in 1984 to the launch of the first element, Zarya, in 1998, we can see a really clear trajectory. Hitting the incredible milestone of 25 years of continuous human presence in 2025 leads us directly into the upcoming Artemis II moon mission, and honestly, well beyond that. Every single day of astronaut health tracking, microgravity science, and that intense physical training we talked about, it's actively paving the way for humanity to leave low Earth orbit. We are using the station right now to develop advanced life support systems, to perfect the robotics we're absolutely going to need in extreme environments, and to understand exactly how long-term spaceflight affects the human body. So, as we close the textbook on today's lesson, I want to leave you with this one thought to ponder. How will the lessons learned in this orbital classroom actually ensure humanity's permanent survival among the stars? The daily life and the extreme challenges overcome on the International Space Station, they aren't just history. They are literally the blueprint for our future. Keep asking questions, keep looking up, and class dismissed.